In today's session, we will be solving a problem statement on variations in rate of water demand. Problem statement is like this. A water supply scheme proposed for a city having a projected population of 1,20,000 person. The annual average daily demand, that is AA of water is estimated at 150 liters per capita per day. To design water treatment plant, transmission system, distribution network, service reservoirs, and pumping stations, determine the following: annual average daily demand, maximum seasonal demand, maximum monthly demand, maximum daily demand, maximum hourly demand on maximum day, absolute maximum hourly demand. We know the annual average daily demand of water is not same throughout the year. It varies season to season, month, day, and hour, depending upon the consumption. Goodrich has given the formula for determining the maximum consumption with respect to the annual average daily demand. Goodrich formula RO Goodrich formula is percentage of P is equal to 180 T raised to the power minus 0.1 into double A double D. It is in percentage, so divided by 100. For the maximum consumption, he has given the formula. Based upon this, the maximum consumption can be determined. For say for one day, it will be P 180. T is one day raised for 0.1, so it will be 180% of the annual average daily demand. If it is not given, we go with this. Otherwise, in the formula, in the problem statement, it will be given, or we can assume maximum seasonal demand will be 1.3 times of annual average daily demand. Maximum monthly demand will be 1.4 times of annual average daily demand. Maximum daily demand will be 1.8 times annual average daily demand, and maximum hourly demand will be 1.5 times of maximum daily demand. Daily demand Maximum daily demand divided by, since it is hourly, 24. So we get all these with the factors. We determine what will be the maximum daily demand, maximum monthly demand, maximum seasonal barriers, maximum hourly demand. All this we find out with applying this factor for the given population. Annual average daily demand. Since annual average daily demand per capita per capita per day is given, liters per capita per day is given 150 liters per capita per day. For 1,20,000 person, it will be 150 liter per capita per day multiplied by 1,20,000, that is population. It will come 1 crore 80 lakhs, that is 18 million liter per day. Maximum seasonal demand is due to, in the summer it is increased due to bathing requirement, gardening and lawn watering, air coolers, cooling systems, and public use. The factor is seasonal variation factor is 1.3 times of annual average daily demand. So seasonal factor variation will be 1.3 into 150 liter per capita per day. So 195 liter per capita per day it has come. For the seasonal demand for the population of 1,20,000, if we multiply by 1,20,000 with 195, we get 2 crore 34 lakhs, that is 23.4 million liter per day for the maximum seasonal demand. Maximum monthly demand is 1.4 times of annual average demand. It is increases due to festivals, tourist influx, agriculture requirements, climatic conditions. Monthly factor is 1.4 times of annual average daily demand, that is 150 liter per capita per day. So monthly, the maximum monthly demand will be 1.4 times of 150 liter per capita per day. So 210 liter per capita per day. Total monthly demand is 210 for 1,20,000 population. It is 2 crore 52 lakhs, that is 25.20 million liter per day. Maximum daily demand is 1.8 times of annual average daily demand. So we multiply by 1.8, we get 270 liter per capita per day. And for the population of 1,20,000, it has come 3 crore 24 lakhs liters per day. So that is 32.40 million liter per day. Maximum hourly demand on maximum day, it is since hourly, the maximum daily demand has to be divided by 24, and then maximum hourly demand factor is 1.5. We multiply by 1.5, we get the maximum hourly demand. We can see here 150 liter per capita per day is annual average daily demand divided by 24, and then multiply by the maximum daily demand factor 1.8, and then again multiply by the maximum hourly demand factor 1.5, we get 16.875 liters per hour per person. Total maximum hourly demand of city 16.875 into 1,20,000, we get 20 lakhs 25,000 liters per hour. So that is 2025 cubic meter per hour. Now absolute maximum hourly demand, that is most important for designing. If we have to design a very good water supply scheme, then we need to consider this, so that there will not be any scarcity or pressure down at the peak of the demand. So this is peak of the peak demand. It is also said the term absolute maximum hourly demand refers to the demand during the maximum hour of the maximum day occurring in the maximum month of the maximum season. So maximum season factor is 1.3, maximum monthly factor is 1.4. If we multiply by this to the maximum hourly demand, we get the absolute maximum hourly demand. That is 150 by 24 is a liter per capita per day hourly demand into 1.8 monthly maximum monthly demand, and then 1.5 factor is for the maximum hourly demand, and this is the seasonal, and this is monthly factor. So multiplying all this, we get 30.7125 liters per hour per person. For the population of more like 20,000, we multiply by this, we get 36 lakh 85,500, that is 368.5 kilometer per hour. With this, completed this problem statement. In the next water quality and monitoring, we will study. Thank you.